everyone, welcome back to my channel. Over the past 3 days, I have some personal matters, so I couldn't record any videos to show Leetcode problems. So that's why today I will be solving three problems to make up for it. So let's start with this problem counting interesting subarray. This is a direct question of the previous 2 days. Okay, the statement is simple. It says given you an array and modulo integer and integer k. You should count how many sub array that following the condition. This condition, okay, that is number of integers in the range. It means in a sub array uh, that have the module mod the modulo equal to k, and the number of that number, the counting of that number mod modulo equals k too. That means we only need to care about the numbers that was value mod modulo equals k. So we only need to focus on that values. So first let's create an array like m that is equal to 1. That's m e, that's the number equal to 1 if the nums e modulo equals k, else 0. Okay, so that we can make sure that we only focus on the number that's match this condition. Okay, now you will have an array that's a binary array that show if the numbers is mod modulo equal to k or not. So the remaining problems is that count how many subarray that have that have the sum of this binary array equals k2. Okay, for example, the answer this array. And try with this arrays. Okay, we will have this binary array is modulo is 3, and then the binary arrays is 1 0 1 1. Okay, so now we should count how many subarray that are interesting. It means have the count equal count modulo equal to k. Like this, the k is 2. For example, the k is 1. So, sorry. Modulo is 3, but k is 0. Okay. For example, k is 0. We only have 1 and 1, 2. What is at 3? Let me see. Okay. We only have. Oh, why it have 2? Let me check the question again. three, three zeros. Number okay. I forgot this the the subarray of length one is also a subarray. This we have two subarray. One is the original array, and two is this element. Why? Because the sum of element in the subarray is equal to zero in the modulo modulo in modulo. Yeah. So the problem switch from the original task to another task is create and to count how many subarray that have the sum on the m this m array that have the equal to k in modulo. So the problem now is to count. So with the constraints, this is really a large constraint. So we need an ON solution, nearly ON. We can solve it using ON power 2 now. Only ON. Okay, but I have a ON solution for this problem. That we using prefix array. Okay, a prefix array means you sum up from the first prefix array. Is the array that prefix e is the sum of all element from the 0 to this position e. Okay, so for example, the m will be a prefix of m will be 1, 1, 2, 3. Okay, and to get the sum from left to right is s1 equals to r. That's the sum of the subsequence from left to right, subarray from left to right. So how to get this sum fast in ON? That's equal to the pre L subtract pre L minus 1. This is why, because pre R mean 0 plus 2 1 plus 2 names R, right? And the pre wait a minute, and the pre L minus 1 is equal to L minus 1. Okay, so we know that, right? We must know that L is not greater than R, large than R. So this is equal to nums L plus 2 nums R. Okay, so you can understand that. That is, let me visualize it. 2, 2, 3, 4, 5. Like R plus 1, 2, 2, minus 1. Let me use this comma to make it more clear. To n. So we have sum from 0 to R minus sum from 0 to L minus 1 is equal to this range. Okay, it's more visually I don't know how to use it, but it's you can see it more clear with this visual. Mhm. Okay, okay, but problem now we should now we know that sum from L to R equal to PL minus subtract 3L minus 1. At the problem, we need to calculate how many. Okay, we only need to care about the modulo. Modulo. This modulo is not a meaning. Okay, equal to K. So what does it mean? We have a theory that that is equal to H module K. Okay. Okay. So we only need to care in each atom of the precision array here. We need to solve the final problem is for each R. We need to count how many how many L how many L that have that yeah okay. Is mean we will need to do some logic calculation. Move from this the left formula to the right and change the sign. Okay, we have okay. Now, if you are at the R position, you so the L position on the L positions that have this value in the module. Sorry, we need to submit is okay. That's mean on with each R position, you need to count on L positions that have this that match this condition or this equation. Okay, to do so now, let me code it, and I think this will be only one submit for me to get accepted this problem. First, we need to calculate the prefixum array. We don't need to create the binary sum because we know that is it we only need to use this equation instead of create a new array. That's so memory consuming. Okay, quick called F for the side. Why we need I need to use one addition element to prevent the zero index problem. So this make my code more cleaner. My code cleaner, not more cleaner. Just cleaner. Okay, let's do for the to size the pre the prefix 0 is equal to 0 because okay now I assume that the array from one index. Okay, it's just for calculation easy. Yeah, it's like the sentinel is a sentinel approach using a sentinel stand on the first of the last, the front of the first or back of the last element to have the code more cleaner. I mean that the code cleaner. Okay, it's redundant, but I code it here to make you feel more clearly, more clearly. So it's for from one because we my code assume that we have an array one index array. So prefix is equal to x minus one plus minus e minus one. And why minus one? Because the original array is zero indexed. Okay. No, sorry, we need to module by module. Okay. 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 Now we have the prefix sum array. All we need is at the r position, the value. Okay. Let's see the value is sorry. We have the value is pre-r module k. Okay. So as you can see, we don't need to store the original prefix sum array. We only care about the modulo. So we do the mod operator here. We need a count. Okay. Okay. We need a map to count. Let's using another map to count how many. Just like to count how many position L that have this value. Okay. How many position L have this value in count the if we have the value need to find k, we need to find the e. If have we answer, if we found that there's some positions L that have the have this modulo, we need to add to the answer. That's it. We need to put the 0 into the array 2. Why? Okay, we need to get that problem is hard to explain, so I can explain it smoothly. But I will try my best day by day, yeah, so that I can interview in some big tech. Okay, now to k plus plus one. It means this position minus one. Okay. Sorry. Yeah, that means we have one more air position that have this value is modulo. Okay. Ye minus one. Okay. As e minus one as this formula. Uh, we need to find this air position that's in previous. That means the portion of L is more smaller than the R position. Why the R now is E? Okay, this E is ER now, and we need to find L. And after we pass, we iterate to the next R. That means E plus one. So now current E is just an L. Okay, let's check the answer if this is correct or not. Wait a minute, there's some problem. Let me check it first. It's one plus it's look so true. make it wrong. Ah, I know because I assume that we have an one index array, but the original array each only zero index, so we need to fall from one to n size of the array instead of less than the n. So let's check it out. Oh, it's still wrong. Let's see what problem here. What problem? That is some problem. Oh, so we need to update before answer because why? This is why because the portion E valid subarray. Uh-huh. So the pre E minus pre E is correct. So we need to update first to so the map the count array contain the E element. But it's still wrong. Let me take it out why it can be wrong. Why can be? It can be. Hmm. Let me check what happened. Zero. Just do some debug here. 0 0. Okay. 1 and 1. We see this array. Okay. 1 and 0. Okay. 3 and 2. Why? Why? What happened? Why does have 2? Is the array 0 1 1 2 3? Oh, 3D also modulo 3 equal to 0. Oh, okay. How to 1 is this value and 1 is this value. So we don't need to do this because when we h follows, we update the e minus 1. That's that's what we don't need to update the free update the 0 position. So now this I think is correct. But I read out, so it's my god a TLE time limit because count too much. So let's submit it again. See how too much is make your performance poor. Okay, you can see